All right, kids, here are your solutions for the May 18th HL Paper 1 in TZ1. All right, so the first question says, what is the molecular formula of a hydrocarbon that contains 84.6% carbon by mass with a molar mass of 142.3? So 84.6% of that mass is the mass of carbon. So what I'm going to do is just calculate what 84.6% of 142.3 is. When we do that, that'll give us the total mass of carbon. Since we know the mass of each carbon atom, we can find out how many carbon atoms we have, because each of these choices has a different number of carbon atoms. There may be another way to approach this, but this is just the first thing that comes to mind for me. So we're going to multiply 142.3 by 84.6%, which would be 0.846. So we're going to do this, like I said, the old way. So 6 times 3 is 18, carry the 1. That will be 13, carry the 1. 25, carry the 2. For the next step, we add a 0. Now it would be 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 4 is 16, carry the 1. 4 times 1 is 1, plus 1 is 5. Then we're going to add another row. So 2 zeros. 8 times 3 is 24, carry the 2. 8 times 2 is 16, plus 2 is 18, carry the 1. 8 times 4 is 32, plus 1 is 33, carry the 3. And 8 times 1 is 1, plus 3 is 11. So now we have to add these 3 rows together. So it's going to be 8, 5, 13, 15, 23, 7, 10, 2, 1. Now to get the decimals, we just take the total number of decimal places and apply it here. So 4 total decimal places. So the total mass of carbon is right around 120 grams. Since each carbon is 12 grams, that means there's 10 of them in the formula. So it's choice C. Which graph shows the relationship between the volume and pressure of an ideal gas? That is an inversely proportional relationship. And choice A is what shows us the graph for an inversely proportional relationship. What is the percentage yield when 7 grams of ethene produces 6 grams of ethanol? We are given the molar masses of both ethene and ethanol. So to calculate percentage yield, it is the experimental value over the theoretical value times 100. The experimental value comes from the product formed. The theoretical value comes from the product started with. Now, because each compound has a different molar mass, we can't compare the number of grams for our experimental or theoretical, so we have to convert to moles. So when we convert to moles, we divide by the molar mass. That means my experimental yield will be moles of ethanol, and my theoretical yield will be moles of ethene. So I have to have, in order to get moles of ethanol in the numerator there, I'm going to take the mass of ethanol, which is 6, and divide by the molar mass, which is 46. If I want moles of ethene down here, I need the mass of ethene down here, which is 7, and the molar mass of ethene up here, which is 28, and we multiply the whole thing by 100, which looks to me like choice D. Which statements are correct about the emission spectrum of hydrogen? The red line is lower energy than the blue line. Indeed, because red light is lower energy than blue light. The lines converge at longer wavelength. Well, remember, longer wavelength means lower energy, and they converge at high energy. The frequency of the blue line is greater than that of the red line. Yes, indeed, because high energy means high frequency. So 1 and 3 are our correct choices, so B is the answer. Which transition on the diagram corresponds to the ionization of hydrogen in the ground state? So remember, N equals infinity is the amount of energy required to ionize. So we're adding energy, enough energy to an electron to make it leave. If we're adding energy, it's promoted to N equals infinity, so it's choice A. Choice B would never occur because if an electron gained that much energy, it wouldn't be able to return back down because it would have been removed from the atom, which describes the oxide of sodium. So this is an ionic compound, so the bonding type is ionic. And ionic compounds will not conduct electricity as a solid, so it must be choice D. Also, since sodium is an alkali metal, when reacted with water, it will produce an aqueous or an alkaline aqueous solution, so we would expect the pH to be high. Which statement is correct? Atomic radius decreases down a group? Nope. First, ionization energy decreases down group 1. Yes, indeed. Remember, we can look at an ice cream cone that has fallen over to remind us of the trend for ionization energy, and we can see it decreases down a group. Which form of carbon is the porous conductor? Diamond. Does not have delocalized electrons. Graphite, graphene, and carbon nanotubes are essentially all the same substance. Graphite is just hexagonal rings of carbon all connected together, not like my hands are showing you anything right now anyways. But each carbon has 3 bonds, so there's extra electron per atom that can become delocalized, making them conductors. Diamonds have 4 bonds per carbon, so all their electrons are tied up in bonds. Molecular geometry and bond angle of the nitrate ion. So we looked at the, why am I doing that? We looked at the structure of the nitrate ion fairly thoroughly this year, and when you draw it, that's the structure you will get. That gives you a trigonal planar geometry, which has a bond angle of 120 degrees. Which metal has the strongest metallic bonding? So the strength of the metallic bond is dependent on the attraction between the cations and the delocalized electrons. So whichever one basically what we want here is the smallest atom with the highest charge. So we've got sodium, magnesium. Let me actually grab a periodic table. This isn't the IB one, but whatever. We've got sodium, magnesium, aluminum, and calcium. So the smallest atom out of all those will be aluminum, and it has the greatest amount of charge, so C. Which molecules have at least one sp2 hybridized atom? Remember, to have sp2 hybridization, you have to have 3 domains around you. So we notice here the carboxylic acid has the carboxyl group. That carbon has 3 domains, so it is sp2 hybridized. This here is the ketone. So what you're going to see here is we have 2 methyl groups, the carbonyl group in the middle. 3 domains means sp2. This one right here we got looks like an alcohol with a double bond. So we got CH2, CH, CH2, OH, 3 domains on that carbon. So all 3 have an sp2 hybridized carbon, which can be represented with only one Lewis structure. So basically what we're looking for is molecules that have resonance. Because if you have resonance, you have multiple Lewis structures. This is methanal. There's no other way to rearrange that. That's benzene has resonance, ozone has resonance, nitrate ions have resonance, so it's choice A. What is the enthalpy of combustion of butane in kilojoules per mole? This is an obnoxious one, and you'll see why. So it's Hess's law. We just have to match our steps to the overall equation and then manipulate them and then add them all together. So first thing I'm going to look at here is butane. Here I find butane in delta H is equals Z. It's on the wrong side of the equation, and there's half as many moles as there should be. So what we're going to do is double and reverse the value for C. So it's going to be negative Z. It's going to be negative 2 times Z. Next thing I see here is oxygen. We're going to skip it because it appears in 2. Then I have carbon dioxide here, 8 of them here, 1 of them there. So I'm going to add 8 times the value for X. And next thing I see here is water. There's water, 10 there, 1 there. So I have to add 10 times the value of y. So what you're going to do is be really tempted to select choice C. I actually did the first time I went through this paper, but that's not the correct answer because it's kilojoules per every 1 mole. And this main equation here shows 2 moles of butane. So it'll actually be half of this for A. Really makes me want to ask the IB, what are you assessing here? Students' ability to complete problems concerned using Hess's law, or to check that they're hyper aware all the time when they're taking a high stress test. Who knows? Which statement is true? In an exothermic reaction, products have more energy. Nope, they have less. In endothermic, products are more stable. Nope, they're less stable. In an exothermic reversible reaction, the activation energy of the forward reaction is greater than that of the reverse, and we have the same thing here for an endothermic. Now, to answer this, the best thing to do is just show a potential energy profile for exothermic and endothermic. So there's exo, there's endo. For the exothermic, that region right there is my activation energy. On the endothermic, that's my activation energy. Endothermic reactions will always have greater activation energy than an exothermic reaction. That's basically the thing that makes them endothermic. So in an endothermic reversible reaction, the activation energy of the forward reaction is greater than that of the reverse. Indeed, because endothermic will always have a higher activation energy. What is the enthalpy of solution of magnesium fluoride in kilojoules per mole? So it gives us lattice enthalpy, enthalpy of hydration for magnesium ions, and the enthalpy of hydration for fluoride ions. So we have to create an energy cycle here. So what we're going to do in this process is take magnesium fluoride, mix it in a little bit of water, and this is the solid, which will cause it to dissolve into aqueous ions. So we're going to have 1 aqueous magnesium ion and 2 aqueous fluoride ions. Now, it doesn't happen all in one neat step. The first thing we have to do before we can make the ions is break apart this ionic compound into those ions. So we're going to take magnesium fluoride and break it up into gaseous magnesium ions and gaseous fluoride ions. Those gaseous ions will then combine with water to dissolve and become aqueous. So this process right here is the lattice enthalpy. So that value is 2926. This value here is the enthalpy of hydration. Remember, these are per mole. So we have 1 mole of magnesium ions. So that'll be negative 1963. And we have 2 moles of fluoride ions. So that'll actually be added to 2 times the value for that. And enthalpy of hydration of fluoride is negative 504. So when we're calculating this arrow, we're going to go around. So it's going to be 2926 minus 1963, minus, even though we're going with the arrow, we're adding, but it's a negative value, so we're subtracting, minus 2 times 504, so choice A matches. All right, which statement is correct? If delta H is negative, the reaction is always spontaneous. No, remember, delta G must be negative. If delta H is positive, the reaction is never spontaneous. No, it can be. If entropy is negative, it can be spontaneous if temperature is low enough. Well, remember, if our delta H and delta S are both negative, then the reaction will always be spontaneous at low temperature. And if delta H and delta S are both positive, then it will only be spontaneous at high temperature. If delta H is negative and delta S is positive, then it will always be spontaneous. So if delta S is negative, the reaction can be spontaneous if the temperature is low enough. Yes, indeed. If delta S is negative, the reaction can be, nope, not high enough, low enough. All right, and it's easy to remember because the negatives mean low. Well, to your brain, the negatives should mean low and the positives should mean high. Which change increases the rate of formation when zinc reacts with excess hydrochloric acid? Well, remember, if we want to change the rate, if we want a higher rate, we need more concentrated, higher temperature, and smallest particle size. So let's see what we got here. Adding water to the hydrochloric acid would decrease concentration. Decreasing temperature would reduce the rate. Increasing the volume of the acid would reduce the concentration, but decreasing the size of the zinc particles would give you smaller particles and a faster rate. What are the correct labels for Maxwell-Boltzmann energy distribution curve? The x-axis is the, I guess you'd say, probability density, the chance that a particular particle has a particular kinetic energy, and the y-axis is kinetic energy. So I know it's not A, B, or D. So when I just saw probability density, I'm not that savvy that I use terms like that, but I know it's not A, B, or D. The reaction between NO2 and F2 gives the following data. What is the overall order? So this is the initial rate method. I have to find two rows where the concentration remains the same for one, but changes for the other. So I'll start with NO2. So I see these first two rows, it stays constant. I double the concentration and I quadruple the rate. If doubling the concentration quadruples the rate, then it would be second order with respect to NO2. Now for fluorine, I have the first and third remain the same. So as I double concentration, rate doubles. That means it would be first order for F2, and the overall order is just the sum of those two, so it would be 3. What is the effect of increasing temperature on the rate constant K? So the rate constant will increase proportionally with temperature. And just think about it here for a second. There's just a simple generic rate law. We know that increasing temperature increases rate. So if the concentration remains constant, then K would also have to increase if that were the rate law that we were following. So rate constant is directly proportional with Kelvin temperature. What is the effect of increasing the temperature on this reaction? It says delta H is negative. That means it's exothermic. So if we increase temperature, it's going to force it back toward the reactants. Since that's going to decrease the concentration of hydrogen ions, so that is going to mean less acidic as we go. So that means the pH will increase. So it won't shift to the right, it'll shift to the left. That'll cause the pressure of CO2 to increase. So what we're doing is pushing it here, reducing the amount of hydrogen ions. These hydrogen ions will combine with oxygen to make water again. So we would expect to see the pH increase as we get less acidic. This looks like it's going to be an ice problem. So 1 mole of nitrogen, 1 mole of hydrogen, 1 mole of ammonia are placed in a 1-liter flask and left to reach equilibrium. At equilibrium, the concentration of N2 is 0.8. What are the equilibrium concentrations of H2 and NH3? So this is indeed an ice problem. I know because I'm given initial concentrations and equilibrium concentrations. So my reactants are N2, 3 moles of H2. My product is 2 moles of NH3. So I'm told I have 1 nitrogen, 1 hydrogen, and 1 ammonia, and at equilibrium, N2 was 0.8. So remember, these are my reactants. That is my product. Reactants decrease over time, and products increase. So nitrogen experienced a decrease of 0.2. Now the stoichiometry tells us that hydrogen would experience a decrease of 0.6 because it's a 1-to-3 molar ratio. And it means that ammonia would increase in concentration by 0.4, also for the same reason. So that means at the end, I have 0.4 of hydrogen and 1.4 of ammonia. So choice B is the only one that matches. What describes HPO4 minus? So remember, amphiprotic means you can either lose or gain a hydrogen, and amphoteric means that you essentially can be an acid or base. So if you take one thing that's amphoteric and mix it in water, you'll generally get a neutral solution because some of it becomes acidic, some of it becomes basic. So with the HPO42, it is amphiprotic because it can gain a hydrogen to become H2PO4 minus, or it could lose one to become the phosphate ion. So if something says it's not amphoteric, go ahead and cross it out, which means C must be the answer. It's really a lot easier to figure out amphiprotic than it is amphoteric. So first figure out amphoteric, and that alone will tell you what the answer is. All right, I've got 3 minutes before y'all kids come back, so I'm going to start moving faster. What is the pH of a solution, which the hydroxide ion concentration is 1 times 10 to the minus 11? So remember, if hydroxide ion concentration is 10 to the minus 11, then hydrogen ion concentration must be 1 times 10 to the third, because these two will always multiply to give you that. If its hydrogen ion concentration is 1 times 10 to the third, then pH is 3. Which statements are correct? Lewis bases act as nucleophiles. So a nucleophile is something that's attracted to positive charge. So generally, a nucleophile will act as a Lewis base by donating a pair of electrons to something else. Electrophiles are Lewis acids. Well, electrophiles are attracted to negative charge, so they will tend to gain a pair of electrons. So yes. And Lewis acids are electron pair acceptors. That is the definition. So 1, 2, and 3. Which combination of acid and base is most likely to have a pH of 8.5 at the equivalence point? Well, if you want a pH that's alkaline, you need to titrate a strong base or a weak acid with a strong base. So we need weak acid and strong base. Hydrochloric acid is a strong acid. Nitric acid is a strong acid. So D is the only one that fits. Which equation shows oxygen undergoing reduction? So what we're going to be looking for is for the oxidation state of oxygen to become more negative. A is the distractor, because you're going to say, oh, oxygen is minus 2. Well, guess what? Fluorine is the only element in the universe that's more electronegative than oxygen. So in this case, fluorine will take its expected ionic charge, making oxygen here plus 2. So if we're going from 0 to plus 2, that shows oxygen being oxidized. Here, oxygen, nothing is happening to oxygen at all. In each case, oxygen is minus 2. Here, we have hydrogen peroxide, in which it's negative 1. And here in water, it's negative 2. So C shows reduction. What are the products of electrolysis when concentrated calcium bromide is electrolyzed using graphite electrodes? So if we're using graphite electrodes, we're going to make the bromine, but not the calcium. So the product at the negative electrode will be hydrogen, because the hydrogen ions in solution will be attracted, and because it's concentrated, that means we have a high proportion of bromine, usually bromide, whatever's concentrated will generally be what's formed. So it's going to be hydrogen and bromine. Which combination would electroplate an object with copper? So remember, we want to attach our thing we want to plate to the negative electrode. We want to have a solution of copper 2 ions. So Z would be the object. Oh wait, no, Y, excuse me, it's Y, that's the thing. Y would be the object. So we can automatically eliminate choice A and C. X would be made of copper. Z would be an electrolyte with copper solution. So X is copper, Z contains copper ions, and Y is the object, so B. What does not affect the mass of products formed in electrolysis? More current means a greater flow of electrons. Duration of electrolysis, the longer you do it, the more you'll make it. The charge of the ions, the lower the charge, the more you'll make. It doesn't matter what the mass of your cathode is. What is the product between hex 3-ene and steam? Remember, when you react an alkene with water, you make an alcohol. The hydroxyl group will attach at the site of the double bond. So if this is hex 3-ene, there's our double bond. So the hydroxyl group will attach there. That would be hexane 3-all. I mean, if you said hexane 4-all, counting this way, you'd actually be wrong, because we have to give it the lowest possible number. So which monomer could create this? I see here we have a repeating pattern that has 4 carbons in a row with a methyl group on either side. So that would have to be butene. You need to have that double bond in the middle there. so that these methyl groups go above and below to produce that. Which is a secondary alcohol. In order to be secondary, the carbon that is bonded to the hydroxyl group has to itself be bonded to two other carbons, so B. A is a primary alcohol. C is also primary, and D is tertiary. What is the name of this compound? All right, so we got to find the longest chain, which is 4 carbons. We're going to give priority to, oh geez, well this is going to be EZ because we got that double bond. So we got to assign priority based on atomic number. So bromine has a higher atomic number than chlorine, so that'll be my high priority, and chlorine my low priority. Here we just have hydrogen and methyl. Whatever has more atoms will be the high priority. So that makes this low priority. Since both of our high priorities are on the same side, it will be a Z isomer. And what we have here is but1-ene with a chlorine and a bromine on carbon 1. So it'll be 1 bromo, 1 chloro, or Z, 1 bromo, 1 chloro, but2-ene. Z, 1 bromo, 1 chloro, but1-ene. Yes, sorry, and C, choice B. Which molecule contains a chiral carbon? So just know that all secondary halogenoalkanes with at least 4 carbon atoms will give you a chiral carbon, because to be chiral, a carbon has to be bonded to 4 unique atoms or groups of atoms. So in the secondary, it's bonded to a methyl group, a hydrogen, an ethyl group, and a bromine, so that would give you a chiral carbon. If it was only 3 carbons, it would be achiral, because that carbon would be attached to 2 identical methyl groups. So what do we have here? Here we have a secondary halogenoalkane. Oh wait, hold on one second. Let me actually draw that out because I see other things that could fit. This one is primary, so that won't work. That one is primary, so that won't work. So the first one here, we got methyl, methylene, CHBr, CH2, and this one we have CH3, CH2, CHBr, CH3. Oh wait, I didn't draw that one appropriately because what we actually have is the double bond. Hold on, let me. Don't talk to me. I'm finishing the video. So they both look secondary, but this one will not fit the bill because there's 2 ethyl groups on either side, right? So it's got to be choice B. Sorry about the music. I got 4 questions to go. No, don't talk. Yeah, it's fine. Which reagents are needed to convert nitrobenzene to phenylamine in 2 steps? Oh my god, that music. So if we're going to take nitrobenzene and reduce it to phenylamine, the first thing we do is mix with tin and concentrated acid. So it's got to already be choice D, and we deprotonate with sodium hydroxide. What is the IHD of this compound? Remember, a ring counts as 1, double bond counts as 1. I have 1 ring, 1 double bond, so 2. What is the ratio of areas of the signals in the NMR spectrum of pentan-3-ol? So let's go ahead and draw out the molecule. 1, 2, 3, 4, 5 carbons. Guys, if you want to be featured in the video, continue to talk. If you don't, please be silent. Everybody be quiet. Don't talk, please. I'm almost done. Pentan-3-ol would be here. So we have 3 environments, 1 there, or 4 environments, 1 there, 1 there, 1 there. There's 6 hydrogens in one, 4 in the other, and 1 in the other 2. So A. And the last question, which would be the most effective method to distinguish between liquid propan-1-ol and propan-2-ol? Well, 1 is primary and 1 is secondary, so I would probably, well, let me just read the choices. Observation of color change when warmed. No, because the color change will be the same. Determination of mass to charge. No, they're isomers, so they'll have the same molecular ion. Determine percent composition, same molecular formula, so same composition. NMR spectroscopy will tell us where that hydroxyl group is. So there it is. I finished just in time. As always, thank you for watching. Don't forget to like and subscribe.